Hello everyone, hope you are doing well. Today we'll learn few more concepts related to algebra. So let's start. The first topic that we will be discussing today is coefficient. As in the previous video, we learned that there are terms in an algebraic expression. So now we will be learning something related to these terms only. And the thing, coefficient is something related to the terms only. Every term in an algebraic expression has a coefficient except the constant term. Please remember this thing that constants do not have a coefficient, but apart from constant terms, whatever terms would be there in an algebraic expression, they will be having a coefficient always and always. Now, this coefficient could be a numerical coefficient or an algebraic coefficient. Numerical coefficient is something which is the number in multiplication with the term. What I mean by it, for example, consider this algebraic expression 5x square y plus 7x. If I ask you to find the coefficient of the term 7x, it means I am asking you the coefficient of the variable x. So the numerical coefficient of x is the number in multiplication with x. 7x is nothing but 7 times x only. So that's why the number in multiplication with x is 7 and therefore 7 is the coefficient of x in the term 7x. Right? Now comes algebraic coefficient. What is an algebraic coefficient and in which case we get the algebraic coefficient? Algebraic coefficient, as written on the screen, is obtained when the term consists of more than one variable. Right? For example, in the term 5x square y, you can see there are two variables. One is x square and the other is y. So in this case, we will be getting algebraic coefficient. How? Because if we have more than one variable in a term, it means each and every variable in that term would be having a coefficient. And how will we find that? In that case, everything which is in multiplication with the concerned variable is considered as its algebraic coefficient. For example, over here, in 5x square y, since it has two variables x and y, so x square would be having a different coefficient and y would be having a different coefficient. If I have to find out the coefficient of x square, so everything present in this term which is in multiplication with x square would be the coefficient of x square. That is why 5y is the coefficient of x square in 5x square y. Similarly, if I have to tell what is the coefficient of y, so I look at this term and see what is in multiplication with my y. It is 5x square. So 5x square would be the algebraic coefficient of y. Okay. And that is the reason why we are calling them algebraic coefficient, because the coefficient of y is consisting a variable in it. Similarly, coefficient of x square contains a variable in it. That is why we are calling them algebraic coefficient. Please remember, coefficients are always of the variables. Constant do not have coefficients. Fine? I hope it's clear to you. Now, let's learn few more things about coefficients in the next slide. So, the first point says when a variable doesn't have any number in multiplication. Like in the previous slide we learned, coefficient is something which is in multiplication with the variable, right? Like 7 was in multiplication with x. Now, there could be situations when there is no number in multiplication with the variable. Then in that case, how are we going to find out the coefficient? Because we have learned that every term, every variable present in an algebraic expression would always and always have a coefficient. So in that case, please remember this rule that when a variable doesn't have any number in multiplication with itself, then its coefficient is assumed to be 1. How? Let us consider an example of the algebraic expression x plus y plus 3z. Here, as you can see, if I talk about the first term, x, the variable x doesn't have any number in multiplication with itself. So I have written the coefficient of x as 1. But how? Because x is nothing. X could easily be written as 1 times x. It would make no change. That's why for any variable which doesn't have a number in multiplication with it, we can assume that there is a hidden 1 with it, and that therefore the coefficient of such variables are 1. Similarly, coefficient of y, again there was no number in multiplication with y, so we assumed it to be 1. And here, since with z there is 3 written in multiplication with z, that's why the coefficient of z is 3. Now, let's see the second point, which says when a term is getting subtracted, then its coefficient would be negative. What do they mean by it? Let us consider the algebraic expression x cube minus y square minus 3z. Over here, as coefficient of x cube is 1, as we have learnt in the previous point, that when there is no number in multiplication with a variable, we can assume the coefficient to be 1. But when we move to the next term, which is y square, it's clearly visible that y square is getting subtracted. So for such terms, the coefficient would be negative because y square is getting subtracted. So the coefficient of y square in general would have been 1 because there is no number in multiplication with it. But since it is getting subtracted, so its coefficient would be minus 1. Similarly, 3z. Normally, if it would have been plus 3z, coefficient of z would be 3. But here, since 3z is getting subtracted, that is why coefficient of z is minus 3. Right? Now, let's look at the last example, the last point, which says, in the algebraic expression, x over 3 minus y plus 3yz. Now, we have discussed the coefficient of y. Since y is getting subtracted, so coefficient of y is minus 1. Right? Coefficient of yz is 3. If I talk about just the coefficient of y, it would be 3z. If I say coefficient of z, it would be 3y. What is new over here is x over 3. How can we find out the coefficient of a term which is in the form of fraction? So, we just need to remember the rule that we have learned, that coefficient means nothing but the number in multiplication with a variable. I cannot say that the coefficient of x is 3 because 3 is not in multiplication with x, it is in division with x. But I can write this x over 3 as 1/3 of x, means 1 by 3 multiplied by x, right? Now see which number is in multiplication with x. It is 1 over 3. That is why the coefficient of x would be 1 over 3. Right? Now, let's move to the next slide to learn more. Now, we will be learning about, we learned about terms, we learned about the coefficient of a term. Now, what kind of terms are there in algebra? So, primarily, there are two types of terms in algebra. First is the like terms and the other one is the unlike terms. They are exactly opposite to each other. So, what are like terms? The terms in which variable and its power is same are known as like terms. For example, in the algebraic expression, x square plus 3y minus 4x plus 7y. 3y and 7y are like terms. Why? Because just focus on the definition. It says in which variable is same. So check, 3y and 7y both have the same variable in them, which is y. Also, there should be one more condition that needs to be satisfied, which is power of the variable should be same. Here, 3y. The power of y is 1. Why? Because y square means y is getting multiplied 2 times, right? So y, if y is written just 1 times, it means y is raised to power 1. So in both 3y and 7y, the power of y is 1. And since the variables are same and the powers of variables are same, therefore 3y and 7y are like terms. Right? Now, unlike terms. The terms which are not like are called as unlike terms. For example, x Again, x in the expression x squared plus 3y minus 4x plus 7y. X square and 4x are unlike terms. Why? Because power of, no doubt the variables are same, but the second condition is not getting satisfied. Why? Because power of x in x square is 2, but the power of x in 4x, it is 1. That is why they are unlike terms. Similarly, x square and 3y, they are unlike terms. Why? Because the variables are different. In x square, we have the variable x, but in 3y, we have the variable y. I hope it's clear. Now, one more important thing that we need to remember is that the order of variables doesn't matter in determining type of a term. What I want to convey from it is, for example, if we consider this algebraic expression p cube plus p square cube minus q square p plus 3p square cube plus pq square. Obviously, p square cube and 3p square cube, they are like terms. Why? Because both of them have a variables p and q in them, right? Also, power of the variable p in p square cube and power of the variable p in 3p square cube is 2. So both the variables have the same power. The second variable q is having power 1. Here also q is having power 1. So they are like terms. But this point which we say order of the terms, it is here in the second case. Look here. If we look at the term q square p and pq square, they might look like unlike terms to them, but we need to focus that our condition is variables should be same. In both the terms, the variables are p and q and p and q. In the first term, the power of p is 1. In the second term also, the power of p is 1. In this first term, the power of q is 2. In the second term also, power of q is 2. So they would be like terms. It doesn't matter that in this term q is written first and in this term p is written first. So here is this reason that order of the variables doesn't matter in determining whether the terms would be like or unlike. Even if the order is not same, then also they could be like terms if the variables and their powers are same. I hope it's clear to you. Now let's move to the next slide to learn more. Now the topic is algebraic expression and polynomial. What is the difference between the two? Often they are considered to be the same, but they are not. There is a difference between them. And what is that difference that we will learn today? As we have learned in the previous video, algebraic expression was something that consists of at least one variable and at least one of the mathematical operations from addition, subtraction, multiplication or division, right? So there was no condition imposed on the power of variable, right? So in the algebraic expression, power of variable could be anything. It could be a negative number, it could be a positive number, it could be a 0, or even the power could be in fraction, right? But the difference in polynomial is that in a polynomial, power of a variable would always and always be a whole number. What do I mean by a whole number? Whole number means it could be 0 or any number greater than 0. And those numbers will not contain the fractions. So all the numbers greater than 0, equal to 0, excluding fractions can be the power of a variable in a polynomial, right? Let's see some of the examples. In the first example, x plus under root y, in this algebraic expression, x is having power 1. So it can be a polynomial or an algebraic expression. But when we look at y is under root y is there. Under root means the power is 1 over 2. So even though y has a power of 1 by 2, it would be an algebraic expression because in an algebraic expression, power could be in fraction. Similarly, in x square plus 1 over z, 1 over z is nothing but z raised to the power of minus 1. Why? Because when I'm writing 1 over z, if I write it in normal form, Here z is raised to power 1. As soon as I move it to the numerator, it is z raised to power minus 1. Right? So, power is negative. But in an algebraic expression, power could be negative. So, this is an algebraic expression. But both of them would not be polynomials, because polynomials cannot consist of such variables which have fractional powers or which have negative powers. Right? But, okay, then what could be the example of a polynomial? X cubed plus y squared. This is a polynomial. Why? Because power of x is 3, which is a whole number, something greater than 0. Power of y is 2, which is greater than 0. So 0 and all the numbers greater than 0 could be the powers of a variable in a polynomial. I hope the difference is clear to you. Now let's move to the next slide, which is types of polynomials. So we learned about polynomials. Now it's time to learn about the different types we have in polynomials. So the first one is monomial. Please remember this thing, that whenever you see the word mono, always remember it is related to 1. Okay, so a polynomial having only one term in it is called a monomial. For example, x is a monomial because it consists of just one term, which is x. Z square is a monomial because it consists of one term, which is z square. Right? Second type is binomial. Again, whenever we see the word bi, always remember if bi is there, it means they are talking about two entities. For example, bicycle has 2 tires in it, right? So a polynomial having 2 unlike terms is called a binomial. Please focus on this thing, unlike terms. We have learnt about it in the previous slides. For example, x plus y is a binomial because it consists of 2 unlike terms. Z square plus 3y plus z square. It might seem to you that there are 3 terms, but no. There are 3 terms, but there are 2 unlike terms in it. Why? Because z square and this z square, they are like terms. Variables are same, powers are same. They are like terms. So, we need 2 unlike terms. There are 2 unlike terms because z square and z square, they were like terms, so they can be added together and we get just one term out when we solve both of them. So our final polynomial is 2z square plus 3y, which consists of 2 unlike terms. That is why it is a binomial. So before marking any polynomial as monomial, binomial, trinomial, we need to simplify the algebraic expression first. If there are like terms in it, we need to add them or subtract them, and then we can tell whether it is a binomial or a trinomial. Right? Now the last one is trinomial. Tri means 3. Wherever the word tri is there, like triangle, it has 3 sides. Similarly, trinomial, it means it would be having 3 unlike terms. For example, x plus y plus 7z, it consists of 3 unlike terms. 3 terms which would be having different variables, or power of variables would be different. If I consider the other example, z square plus 3y plus z square plus 4z, it looks like there are 4 terms, but again, focus on this thing, unlike. Z square and z square were like, so we will add them first and we'll get 2z square, then there is 3y and 4z. We have 3 unlike terms, that is why it is a trinomial. I hope it's clear to you. Okay, so if you have any doubt, you can ask in the comment section. And thank you for your time. Bye-bye.
Uh,